Hello, Chemistry 10HH students. This is Mrs. Altman, and we are on video number 28, Types of Chemical Reactions, Part 3. Here are our objectives for today's video. Pause here. So as we did the video number 27 in class practice, I probably told you for certain problems that there was going to be an easier way to do the problem. And this would occur specifically when we were changing the volume and we wanted to know what the new molarity would be, the new concentration. So typically we would calculate the number of moles of the solutes and then divide by the new volume. And there's nothing wrong with doing it that way. That just takes a little bit longer. But this is a really, really common, I guess, sort of shortcut that we can take the molarity of the initial solution times the volume of the initial solution and make it equal to the molarity times the volume of the final solution. The reason why this works is because we're pretty much saying moles before is equal to moles after, since volume times concentration is moles. And we're following the law of conservation of mass, so the moles has to be equal before and after. Pause here. Okay, I will work through this. Some of you are probably sitting here wondering, do I need to convert the milliliters to liters? And you actually don't, since they're both in milliliters, but if one were in milliliters and one were in liters, then you would have to. I round this to 3 sig figs. Take a look at another problem. Pause here. Doesn't really matter which one I make 1 and which one I make 2, so long as I'm being consistent here. Since I left the 500 as milliliters, my final answer as milliliters, had I converted it to liters and done 0.5, I would have gotten 0.167 liters, which is equally correct. Pause here. So we're going to be doing an experiment. I'm tentatively saying in a couple weeks, but we'll see how the school year goes, where we're going to be doing a dilution. So typically under ideal circumstances, we're using what's called a volumetric flask. I will show you during the in-class practice what one of these looks like. It's just a flask that is calibrated to a specific volume. So if I have a 250 milliliter volumetric flask, the only thing that can do is measure 250 milliliters. A sort of rule of thumb that is especially true with strong acids is that you're going to add a little bit of water to the volumetric flask before you add any sort of solids or concentrated solutions. The reason why you do that is because oftentimes the dilution of certain substances can be super, super exothermic. So you want to add a little bit of water to it to absorb some of that heat. For certain things like salts and for things that just in general don't have a ton of acid base reactivity, that's not always important. But if you're not sure, always add a little bit of water to the flask first. It's never really wrong to do so, and it can just make your experiments overall a little bit more safe. Right. That is all for right now. Thank you so much for watching and have a great night.